Good morning, everyone. We're now dealing with revision for Friday's exam. So we've already done a few papers. We've done the 2020 paper. So I'm taking this one because some of the questions here are a bit challenging. So let's have a look at what we're going to deal with. Right, so let's start with question 1.1, limits. So first question, determine. So 1.1.1, you have ln y is equal to the limit as x approaches 0, and then you have a fraction. So what do? You first substitute 0 and check what do you get. Right. So if I substitute a 0 there, that's going to be 2 times 0 divided by tan of 0, and 0 times 2 is 0. Tan of 0 is also 0, so this is indeterminate form. Alright, so that is indeterminate form. So what we're going to do is, we're going to differentiate, we're going to use Aristotle's rule. Differentiate the numerator, differentiate the denominator. So remember, on the left hand side, you still have ln y equal to the limits as x approaches 0. Differentiate the numerator, which is 2, differentiate the denominator. Derivative of tan is going to be sec squared. So what do? You indicate here that this is now f prime x and this is g prime x. So remember, you call the numerator f, the denominator g. So you show that you differentiate the numerator individually, denominator individually. You are not using the quotient rule here. Right. So what do? You differentiate and then simplify. So therefore, ln y is equal to the limit as x approaches 0. So that's going to be 2 times 1 over sec squared is going to be cos squared. So always simplify after you use the rule, or after you differentiate, you simplify and then resubstitute. So this is going to be 2 cos. Now when you do this on the calculator, you open bracket cos, substitute your 0, close it, and then square. This is how you do it on the calculator. So ln y is equal to, we know that cos of 0 is 1. So therefore 1 squared is 1 and 1 times 2 will be 2. So ln y is equal to 2. That is our answer. The next question, 1.1.2. The value of y for 1 mark. Right, so the value of y. So from question 1.1.1, we know that ln y is equal to 2. Okay, so now we need to solve for y. This is a log equation. So if I want to make y the subject of the formula, I need to convert from log form to exponential form. Alright, so the base of, remember this is natural log, so the base of your natural log is e, if it's not shown. Okay, so your base is e. So therefore, what you do is you convert from logs to exponential form, so y is going to equal to e to the power 2. The base of the log becomes the base of your, it becomes the base in your exponential equation. So the base in your log equation becomes the base in your exponential equation. Right, so then you can work out e squared. What is e squared? Press shift, ln 2 equals to, what do we get? 7,3, 8, 9, and that is your 1 mark. Right, so that was your first question. So 1.2, determine the limits as x approaches 0, and then you have ln sec x divided by x times e to the power 2 minus x, and this is 3 marks. Alright, so now let's do the substitution. Alright, so step 1 is always substitute and check what you get. So in order to do a substitution, I need to change sec to 1 over cos. So this is going to be ln 1 over cos x divided by x times e to the power 2 minus x. Right, so now we are replacing x with 0. So that's going to be ln 1 divided by cos of 0, and here this is 0 times e to the power 2 minus 0. So what happens here? We have ln cos of 0 is 1, so basically you have 1 over 1. Let me just write this down. This is 1 over 1, and you have 0 times anything is 0. So now ln of 1, from your log loss, ln of 1 is 0, so therefore you get 0 over 0, and this is indeterminate form. Right, now we know that we have to differentiate the numerator and then differentiate the denominator. Right, so when you differentiate the numerator and denominator, what do we get? So here we got ln of sec. You should know by now, obviously, y is equal to ln f of x. So the derivative of ln f of x is going to be f prime x divided by f of x. So if I want to differentiate ln of sec x, then f of x is sec. So f prime x will be the derivative of sec x, which is going to be sec x times tan x times the derivative of x, which is 1. And now, in the denominator, this is x multiplied by e to the power 2 minus x. So if it is multiplication, we use the product rule. Okay, so it's the product rule here. So the product rule, if you have y is equal to u times v, this is multiplication, then the derivative is going to be, write down the first, differentiate the second, u v prime, plus write down the second, differentiate the first. Or you can do this part, it's addition, it's up to you. Right, so this is my x first term, differentiate e to the power 2 minus x, which is going to be e to the power 2 minus x times the derivative of 2, which is 0, and the derivative of minus x, which is minus 1. So that's my u v prime. So there's a u v prime plus v, which is e to the power 2 minus x times u prime. So where am I? Times u prime. The derivative of x there is 1. Alright, so now let's see what we get. Let's simplify first. Let's see, do we really need to simplify there? Okay, let's just multiply this part. So this is equal to the limit as x approaches 0. If I want to simplify this here, I will try and let me rewrite everything. Right, sorry, sec. I need to rewrite it as 1 over cos before I use my calculator. So sec is going to be 1 over cos tan. If you want to, you can write it as sine over cos, but let's just leave it as it is for now. And then negative 1 times that will be minus x e to the power 2 minus x plus e to the power 2 minus x. I want to check now, because here, if I write tan as sine over cos, this cos is not going to cancel. It's going to become sine over cos squared. So it's pointless to go and write it. Let's do the substitution and let's see what happens. So this is equal to 1 over cos of 0, and then I got tan of 0 here, minus 0 e to the power 2 minus 0 plus e to the power 2 minus 0. Wherever I see x, I'm replacing it with 0. And don't forget, I forgot here, but remember, what did we do here? You must indicate that you found the first derivative of the numerator, first derivative of the denominator. So you identified the numerator as f, denominator as g. Okay. So now, let's go back. What do we get? Alright. So, what do I know? That tan of 0 is 0. Cos of 0 is 1. That's my numerator. Alright. In the denominator, 0 times any number is 0. 2 minus 0 is 2. So that's going to be e squared only in the denominator. Can you see that? So 0 divided by 1 on the top is 0. And then I got 0 divided by e squared, because 0 plus e squared is e squared. So e squared is a number. 0 divided by any real number is 0. And that's what we get here. Right. Okay, so the mistake was identified here. Thanks for identifying the mistake. I wrote down the formula f prime x over f of x, but I forgot to do the f of x part. So let's look at how it's going to affect this solution. Right, so let's go back. Here is the mistake here. So I went ln of sec, so that was f prime x, sec x, tan x, all divided by, f of x, which is sec x. So this is what I forgot to write down. Okay, so now what will happen here? Alright, sec and sec will cancel. So therefore, this part here does not exist anymore. It's just tan x now. Can you see that? So I don't have to worry about that. Tan of 0 is still 0, and 0 divided by anything will be 0. So lucky the mistake did not affect my final answer there. Alright. Right, question 2.1, common question. Given y is equal to cosec x, determine the derivative dy over dx by making use of the derivatives of sine and cos. Alright, so what do we have? We got y is equal to cosec x. So what you're going to do is write it as 1 over sine x. So now you have your 1 over sine. Okay, so now this is a fraction. So let's call the numerator f, denominator g. So fraction. So therefore, we are going to be using the quotient rule because it's division. Right, so the quotient rule, we're going to go with dy over dx. So I identified the numerator as f, denominator as g. So the quotient rule will be copy the denominator, differentiate the numerator, minus, copy the numerator, differentiate the denominator, all divided by the denominator squared. So my denominator there is sine x, differentiate the numerator, the derivative of 1 there is 0, minus, so that's g, f prime minus f, which is the numerator, 1, and the denominator will be g prime. What is g? G is sine, so g prime means the derivative of sine, which is cos x, all divided by the denominator squared, so that's going to be sine x all squared. Right, so now let's simplify. So here 0 times sine x will be 0, and then we just have minus cos x all divided by sine squared. Now, we know the derivative of cosec. The derivative of cosec is negative cosec times cos. If you check your table of derivatives, let's see how we're going to get it. Alright, so the trick here is to split up sine squared, write it as sine times sine. So that's going to be minus 1 over sine x times cos x over sine. So you write it as a fraction times a fraction. So here's your fraction 1 over sine, and here's your fraction cos over sine. If you go back to the previous step, minus 1 times cos is minus cos, and sine times sine is sine squared. So now, from your identity, remember 1 over sine is cosec. So you got minus 1 over sine, but it's going to be minus cosec x, and cos over sine is going to be cot x. Right, so simplification here. Make sure you get full marks. Alright, we move on to the differentiation. The question on differentiation where simplification is not required. This is where you must get full marks for using differentiation. So here 2.2.1 we got y is equal to 10 to the power x ln a divided by cos of ax. So this is what we are dealing with. We are dealing with y is equal to a to the power f of x. This is what we are dealing with. A, which represents a number 10, your function of x, which happens to be a fraction. So the derivative here, dy over dx, is going to be a to the power f of x times ln a times f prime x. That is a formula. There's no need to introduce ln on both sides. But if you do introduce, it's correct. Just that you're going to make it more louder. The fact is, this is a to the power f of x, so let's differentiate. So we got dy over dx is equal to, so there's my a to the power f of x. So the first part is copied down as it is. You can see that it will be 10 to the power x ln a divided by cos of ax. So that's my a to the power f of x times ln a. So that's going to be times ln of the base, which is 10. So that's times ln a times f prime x. So that's times now f prime x. Okay, so what is f of x? F of x here is a fraction. So you can see that this is a fraction. So you're going to use the quotient rule. Because you have a numerator which is a function of x, denominator which also has a function of x there. So if there's x in the numerator, x in the denominator, it's going to be the quotient rule. We just did the quotient rule, I'm not going to write down the formula. So the quotient rule, let me introduce a bracket there. And we know it's all divided by what? G squared. So I know I'm going to have something squared in the denominator. So that's the quotient rule is G, copy down the denominator, which is cos ax, differentiate the numerator. Now be careful, ln of a represents a number. So if I have y is equal to x times ln 2, what is ln 2? Work out ln 2 on the calculator. What is ln 2? Round it up to this one decimal place. 0, what? 0,7. So it means x times 0,7. So it means 0,7x. So what is the derivative of 0,7x? The derivative is 0,7. Sorry, why am I right? The derivative is 0,7, which is actually ln 2. Same thing. Can you see that? Now, so what is the derivative of x ln a? It's just going to be ln a. So now, that's g f prime minus f, which is x ln a, and then g prime, the derivative of cos of ax. What is the derivative of cos ax? It's going to be, let us erase this. The derivative of cos ax is going to be minus sine ax times the derivative of ax, which is a. Don't forget that. And this whole thing is divided by the denominator squared, so that's cos ax all squared. Simplification is not required, so this is your final answer. You will get full marks at this stage. Let's move on to the next one. Right, next one, 2.2.2. We got e to the power bx. This is ln of ax squared minus bx plus c. So this is multiplication. So if it's multiplication, that means you got y is equal to u times v, because you got a function of u represents a function of x e to the power bx, and then you got a different function of x here, which is v. So therefore, this is going to be product rule. The product rule is write down the first, differentiate the second, plus write down the second, differentiate the first. Whether you're calling it u, v, f, g, it's up to you. Okay. So now, if you want to, you can do it individually, but it's unnecessary. Let's just do it in one step here. So we got dy over dx is equal to, so now, u is e to the power bx. V prime means differentiate ln. Okay, which we just did previously. Remember where I made a mistake and I forgot to write down the denominator then. So this is ln of f of x. So the formula is going to be f prime x divided by f of x. So this is going to be the derivative of ax squared is going to be 2ax. Derivative of minus bx is minus b. Derivative of plus c is going to be 0. Derivative of a constant is 0. So that's f prime x divided by f of x, which is ax squared minus bx plus c. So that's our multiplication there. That's my u times v prime plus v, which is, v is the original second term there, which is ln ax squared minus bx plus c times u prime. So what is u prime? U prime is the derivative of e to the power bx, which is e to the power bx times the derivative of bx, which is v. Right, and that is it. How many marks was this one? This was the easy one. 3 marks. Right, so this here was 3 marks. Simplification not required. We leave it like this, as it is. Alright, so let me give you 2 minutes to try this one out. Inverse sine. Right, 2.2.3, y is equal to arc sine of 10 to the power 4x. So what are we dealing with here? We are dealing with y is equal to arc sine of your function of x, f of x. So the derivative here, dy over dx, is going to be f prime x, all divided by the square root of 1 minus f of x, all squared. So what is f of x? My f of x here is 10 to the power 4x. So then f prime x, the derivative of 10 to the power 4x is what we just did in the previous example. This is a to the power f of x. So this is going to be 10 to the power 4x times ln 10 times the derivative of 4x, which is 4. Okay, so that is going to be your f prime. So let's do it here. Right, let's answer the question now. dy over dx. So it's going to be f prime x, which is 10 to the power 4x times then 10 times the derivative of 4x, which is 4. That is my f prime x. All divided by a square root of 1 minus. So 1 minus f of x, the same f of x. There's my f of x here, which is 10 to the power 4x all squared. You must get full marks at this stage. You don't have to go and square this. But if you want to, 2 times 4x will be 8x. Okay, that's a power raised to a higher power. But the fact is, you must get full marks at this stage. Okay, now I have seen a different method where students remember that how you derive inverse sine. So let me just show you a different technique here. So if I got y is equal to arc sine, so let's call this method number 2. So we got arc sine of 10 to the power 4x. Then if you want to come out of your inverse function, then what you do is you put sine on both sides. So if I go sine of the left hand side and sine of the right hand side. So what happens if you introduce sine on both sides? So the whole idea of introducing sine is so sine and arc sine, they basically cancel each other out, and we have just 10 to the power 4x is equal to sine y. There's nothing wrong with doing this. You can do this if you want to. Now we have a function here of x, of y. This is going to be implicit differentiation. So if I want to differentiate now, I'm going to go d over dx of both sides. I'm differentiating with respect to x. So d over dx of sine y, that means d over dx of 10 to the power 4x. So the derivative of sine y with respect to x, you know the shortcut here. The shortcut is to differentiate sine y, which is going to become minus cos y times the derivative of y is 1. But remember, when you're differentiating y, what do you multiply by? dy over dx. Clear with that? And on the right hand side, you have, well, 10 to the power 4x, we just dealt with it. That's going to be 10 to the power 4x times, then 10 times the derivative of 4x, which is 4. So now, all you do is make dy over dx the subject of the formula. And what do we have now? We have 10 to the power 4x times, then 10 times 4 divided by minus cos y, and you must get full marks at this stage. Okay, this is fine because the fact is you wanted dy over dx. Now you might wonder, what happened here? This is minus cos y, and that is sine y. Okay, so you always can go and derive it using your square identities. So although this is all unnecessary, but just for your understanding, we know that sine squared y plus cos squared of y is equal to 1. Okay, sine squared plus cos squared is equal to 1. So now, if I go cos squared of y is equal to 1 minus sine squared y. Okay, then cos of y is equal to plus or minus the square root of 1 minus sine squared y. Right, so in this case, in order for us to make this look exactly like that, we take the negative. So there's two possibilities here. Okay, one where cos is positive or where cos is negative. But you can take any one you want to because you are not given a restriction. Okay, you are not told that this is the first quadrant, second quadrant, third quadrant, or fourth quadrant, but I'm just showing you that cos of y is minus the square root of 1 minus sine squared y. 1 minus, and what is sine of y? Remember, what is sine of y? Sine of y is equal to 10 to the power 4x, so this is 10 to the power 4x all squared. If I take this information and transfer it here now, so this becomes 10 to the power 4x times then 10 times 4, and then I have my negative here, and then I have my negative 1 times the square root of 1 minus 10 to the power 4x all squared. And then what happens now? You can see this negative and negative will give you the positive, and you get back to the same thing. Alright, but if you're using this technique, you don't have to go all the way here. The fact is, dy over dx is what we're looking for, and you can leave your answer like that. Alright, so I just realized my mistake while I was cleaning the board. I was thinking integration. When you integrate sine, it's minus cos. Okay, my mistake was here. Right, so that's it. Now it will work out perfectly. Right, so the derivative of sine is cos, so not supposed to be the negative. Take out that negative there, so we take out the negative here too. Okay, so basically I'm going to take the positive result here, and it works out perfectly. Alright. Right, so yeah, let me just go back. When you integrate sine, it's minus cos. But when you differentiate sine, positive cos. That was the mistake. Right, our next question, 2.3, determine dy over dx with the aid of logarithmic differentiation. And this is what we're given. So, what do we do with the aid of logarithmic differentiation? That means we're going to introduce logs, or natural logs is better, on both sides. So we're going to go ln of y is equal to ln of cos 3x to the power minus 2x plus 1. Right. Introduce natural log on both sides. So now we can bring down the exponent, so that becomes the square root of minus 2x plus 1, and this is ln absolute value of cos 3x. This is ln absolute value of y. Right. So now look at the right hand side. It's a product. It's multiplication, function of two different functions of x. So we're going to be using the product rule. Right. So this will be the product rule. So we need to differentiate both sides with respect to x. So we're going to go d over dx on the left hand side, and d over dx of the right hand side. Right, so the derivative of ln y with respect to x, the derivative of ln y with respect to x, that is implicit differentiation. So the derivative differentiated, Using the rule, the derivative of ln y is 1 over y, and what do we do? Multiply by dy over dx. Right, so here, product rule, where did I get this? Negative number was not here. Right, so product rule is, copy down the first, which is the square root of minus 2x plus 1. That's my u. V prime, differentiate ln of cos 3x. The derivative of cos is going to be minus sine 3x times the derivative of 3x, which is 3. All divided by cos 3x. You can see ln f prime x divided by f of x plus. So that's write down the first, differentiate the second, plus write down the second ln of cos 3x and differentiate the square root of minus 2x plus 1, which is going to be half into minus 2x plus 1. Half minus 1 is minus half times the derivative of minus 2x, which is minus 2, and the derivative of 1 is 0. So that is the chain rule. You use the chain rule when you have a power which is a number. Okay. So now you need to make dy over dx the subject of the formula. But the main job is done. It's just to multiply by y on both sides and you're done. So dy over dx is equal to, you multiply by y on both sides, so you end up with the square root of minus 2x plus 1 times minus 3 sine over cos is 10, and here let's see what happens here. So here this 2 and that 2 will cancel, because minus 2 plus 0 is minus 2, so minus 2 and 2 that will cancel. So this is a negative times a positive, which is negative, and I got ln cos 3x, and then if I take this to the bottom, the negative half will become a positive half, which is going to be the square root of minus 2x plus 1. This 2 and that 2 cancel. Right, so that was 2.3. Right, 2.4.1, make a neat rough sketch for the graph of y for the range 0 to pi. So this is the inverse cos graph. Okay. So in order to know how to sketch this graph, obviously you must know the actual cos graph. So you must know the actual cos graph. So if I got y is equal to cos x, let me go 0 pi over 2, which is 90, pi, which is 180, and there's your 1, there's 1, negative 1. So you should be familiar with when x is equal to 0, y is equal to 1, that's your cos graph. When x is equal to pi over 2, then you come down to 0. When x is equal to 180, you reach negative 1. So now for the inverse cos graph, what to inverse? You're going to swap the x and y values. Okay. So you're going to have 0, and this is going to be all the values on the x-axis will now be plotted on the y-axis, and all the values on the y-axis will be plotted on the x-axis. Alright, so this is going to be 0, pi over 2, and pi. And there's your positive 1 and negative 1. Can you see that? Swap everything. So what do we know? When x is equal to 0, y is equal to 1. So there's a point here. When x is equal to 90, y is equal to 0. There's another point there. Right. Then when x is equal to 180, y is equal to minus 1. So, how is this going to look? So you're going 0, you're going there, that's 180, that's 90, which is 0, 180, which is negative 1. So that is your graph from 0 to pi. There's your 0 to pi. Okay, so this value here is, this is minus 1 pi. You can see that, you can test it out. You can test out your value. You can put minus 1 here. When x is equal to minus 1, put inverse cos minus 1. What do you get on the calculator? Shift cos minus 1. What do you get? Try it out. Shift cos minus 1. What do you get? You get 180 degrees, which is, you can always test out each value. Right, so that is your graph. Then derive the formula to determine dy by dx if y is equal to inverse cos. So what do? You get out of this inverse function, you put cos on both sides. So I'm going to go cos of y is going to be equal to cos of arc cos x. So why do I do this? Because I got cos of arc cos. So they cancel each other out basically. You have to just x. So cos of y is equal to x. So now I need to differentiate both sides with respect to x. So I'm going to go d over dx of the left hand side, d over dx of the right hand side. So the derivative of cos y and the derivative of x. So what is the derivative of cos? The derivative of cos is going to be minus sine y times the derivative of y, which is 1. And this is implicit differentiation, so you're going to multiply by dy over dx. And what is the derivative of x? It is 1. And now we make dy over dx the subject of the formula. So dy over dx is going to equal to 1 divided by, let's put the negative here. So that's minus 1 divided by sine y. Right, now we need our answer in terms of x. So we have sine y here. So now from your square identities, we know that sine squared y plus cos squared y is equal to 1. So therefore, sine squared y is equal to 1 minus cos squared y. And now we take the positive square roots. The square root of 1 minus cos squared y. Why do we take the positive? Because in this range from 0 to pi, the sine graph is positive. Sine is positive in the first quadrant. From 0 to 90, it's also positive from 90 to 180. Because remember, when you're taking the square root, it's both plus or minus. So I'm only taking the positive here. Right, so what do we do now? Sine y is equal to the square root of 1 minus cos squared y. So go back and replace sine y. So therefore, that's going to be minus 1 over sine y, which is the square root of, I forgot to do one more thing here. One more thing, which is the square root of 1 minus cos y all squared. But what is cos y? Cos of y, what is cos y? Go back. Cos of y is x. So this is x, so that's going to be 1 minus x squared. And that's how you derive the formula for inverse cos. You must get full marks no matter what comes out for this type of question. 2.5 given sine of 5x minus 2y is equal to 4. Determine the derivative. Now calculate the derivative dy over dx. So what are we going to do? We're going to find the derivative, differentiate both sides with respect to x. So we are differentiating sine of 5x minus 2y on the left, which is equal to 4, so we differentiate 4 also. Right, so the derivative of sine of your function of x is going to be cos. Right, positive cos. Derivative of sine is cos of whatever you have here, 5x minus 2y, times now the derivative of 5x minus 2y. So the derivative of 5x is going to be 5, and the derivative of minus 2y is minus 2, but I'm differentiating y there, so I need to multiply by dy over dx. Remember, it's implicit differentiation. Right, and then on the right hand side, the derivative of 4, which is 0. Right, so now, so in this case here, if I remove the brackets, let's see what happens. That's going to be 5 cos of 5x minus 2y, and then I have minus 2 cos of 5x minus 2y multiplied by dy over dx, and the whole thing is equal to 0. Okay, so now if I take this to the right hand side, I have 5 cos of 5x minus 2y is equal to 2 cos of 5x minus 2y times dy over dx. So therefore, 5 cos of 5x minus 2y all divided by 2 cos of 5x minus 2y is equal to dy over dx, which is equal to just 5 over 2. I took the long way here. Right. I just did the long way by removing brackets, but the short way will be, you can see, I'm sure you must be thinking, the shortcut will be just divide by whatever you have there. So I could have done this here. I could have went, let me just rewrite it there. Cos of 5x minus 2y multiplied by 5 minus 2 times dy over dx is equal to 0. The fact that this is multiplication, I can divide that. So I'm going to go 5 minus 2 times dy over dx is going to equal to 0 divided by cos of 5x minus 2y. So we got 5 minus 2 times dy over dx, and as long as cos of 5x minus 2y is not equal to 0, 0 divided by that will be 0. Okay, and then now I got minus 2 dy over dx is going to equal to minus 5. You can see that? So therefore, dy over dx is going to equal to minus 5 over minus 2, which is the same as 5 over 2. This is shorter than that, but you come to the same answer, you can see it. Right, let's deal with question 3. Our differentiation applications here. So we're given f of x is equal to 2x cubed minus 4x squared minus 8x plus 8. So what do we need to do? We need to find the turning points, we need to sketch, we need to draw a table of values, we need to sketch the graph, and we need to find the x-intercept of the graph using Newton's method. Right, the x-intercept that's very close to 0,7. So let's see what we're going to do. So 3.1.1, we have f of x is equal to 2x cubed minus 4x squared minus 8x plus 8. So now we find the first derivative f prime x. So the derivative there, 2 times 3, that will be 6x squared minus 8x minus 8. And then you now at the turning points, f prime x must equal to 0. So you make the whole equation equal to 0. So you take this, replace it here. So that's going to be 6x squared minus 8x minus 8 equals to 0. You must write down the statement f prime x equals to 0 first, then you will substitute. Okay. Now, this is a quadratic and this we factorize. Yes? Right, so if you don't have to factorize, if you want to use the quadratic formula, you can. Alright, but since you said it can be factorized, let's factorize. So what can we divide by? I can divide by 2. So if I divide by 2, I'm going to get 3x squared minus 4x minus 4 equals to 0. So now, what are the factors here? So I know for a fact that 3x squared can only be 3x times x. So now what are we going to do here? We're going to put a negative here, positive there, and 4 will be 2 times 2, not 4 times 1. Let's check. 3 times minus 2 is minus 6. And then 2 times 1 is 2. Obviously it has the x and the x there, but I'm not interested in that. I'm interested in the middle term, the coefficient. Minus 6 plus 2 gives me minus 4. There's my minus 4. That means this is correct. Okay. So now 3x plus 2 is equal to 0, or x minus 2 is equal to 0. So I've got 3x is equal to minus 2, so x is equal to minus 2 over 3, or x is equal to 2. Now, these are the x coordinates of the turning points. We need to find the corresponding y values. When x is equal to minus 2 over 3, what is y? So we're going to go f of minus 2 over 3, and we substitute into the original equation. So that's 2 sub 2x cubed minus 4x squared minus 8x plus 8. We will get an answer. And then we will do the same for x is equal to 2. Right, so the first time we are substituting negative 2 over 3. That's minus 2 over 3. Minus 2 over 3. And the second time we are substituting just 2. So let's see, what do we get? So we have 2x cubed minus 4 x squared minus 8x plus 8. So we are substituting minus 2 over 3, and we get 296 over 27. Right, so we get 296 over 27 here. And then for the second time we are substituting 2 So I'm getting negative 8. Right. Now let's just write this down. So we got our turning points there and there. Right. So now, first time when our first turning point there, minus 2 over 3, which is minus 0, 667. Right, and then 296 over 27. What is that? 10,96. 963. Right, and this one we can see clearly what it is. 2, negative 8. Right. So clearly now, if you compare on the graph, there's only 2 turning points for this cubic graph. This is the maximum because this is higher up. You compare the y values. This will tell you that this is the maximum turning point. And this one here will be your minimum value. Right, so that was the first one. 3.1.2 now. Draw up a table of values for x and f of x. So let's do it here. 3.1.2. We got x and f of x, which is equal to 2x cubed minus 4x squared minus 8x plus 8. So we draw up a table of values from minus 2 to 4. Right, so that is simple. Your calculator will do all that for you. So you're starting at minus 2, minus 1, 0, 1, 2, 3, 4. Right. You don't have to go individually and do the sub. So all the calculators can. But you got the table function. So all you do is you're gonna go mode and number 3 on most Casios. On this Casio it's number 7. This one here is number 7. F of x. What is my f of x? You know how to type that out. You press 2 and then you go alpha close brackets to get x on the calculator. So remember it's alpha close brackets. Alpha is next to shift. And then you go the power 3. And then you got minus 4x squared, so that's minus 4 alpha close bracket again to get x squared minus 8x plus 8, and then you press equals to, so there's your f of x typed out on the calculator. And now you press equals to, it asks you for a start value. So we are starting at negative 2, so you're going to type in minus 2, then you press equals to, then it asks you for an end value. We are ending at 4, so you're going to press 4 equals to step value now. Step value is the difference between each coordinate here. We have a common difference of 1 there, you can see that. So step is 1 equals to, and then you get the table. So when x is minus 2, y is minus 8. And we just got it here. Remember that? Minus 2, minus 8. And then the next one is minus 1 and 10, 0 and 8, 1, negative 2, 2, negative 8, 3, 2, 4, 40. Okay, those are the values. Now, what do we need to do? Draw a neat graph of f of x between these values. Right. It's just a rough sketch, but it must be neat. So where are we going from minus 2 to 4? So we're going that's minus 0, let's go minus 1, minus 2, minus 1, minus 2. This is 1, 2, 3, 4. 1, 2, 3, 4. Right, so that's our domain. I mean, the one that we are given from minus 2 to 4. Now, how do you plot your cubic graph? That's your y-axis, that's your x-axis. So now, what you do is you go for turning point first, always. Always label your turning points first. So what are the turning points here? We got 2, negative 8, minus 0,667 and 10,963. Alright, so let's go for okay. So obviously I'm not going to go and start measuring minus 1, minus 2, minus 3 and 10 up and look at this value, 40. We're not going to go and measure 40. And it must be a neat rough sketch. The whole idea is to find out where this graph is going to pass through the x-axis. Okay. So now, one turning point minimum. Before we do that, we should know the shape of the graph. So the shape of the graph, you have y is equal to ax to the power 3 plus whatever you have there plus bx squared plus cx plus d. We're not interested in that. We are interested in the value of a, the coefficient of x cubed. If your a is positive, then your graph reaches maximum first, minimum second. Okay. If your a is negative, then your graph reaches minimum first, maximum second. So clearly, let's have a look at our example here. Right, so our example here, we have a 2. That's a positive 2. So if it's a positive 2, that means 2 is greater than 0. That means it's maximum first, minimum second. Right, so let's do that. So what do we have here? Minus 0,667, somewhere around here. In between 0 and negative 1. 10,963, maybe somewhere around here. Right, so that is our turning point there. Okay, that's one turning point. What's the other one? Minimum value. 2, negative 8. So that's 1, 2, and then I'm going maybe somewhere around here, negative 8. So that is my minimum turning point. Right, so that is maximum, that is minimum. Next thing to do is y-intercept. So, what is the y-intercept of this graph? The y-intercept here is when x is equal to 0, y is equal to minus x. Sorry, when x is equal to 0, y is equal to positive x. So your graph, if this is 10, what was this here? Minus 0,667. So that is minus 0,667 and 10,963. That is one turning point. So if this is a 10, maybe 8 could be somewhere around here. You understand that? It's just a rough sketch. So you're going to be coming down here. So let's go there. You're going to come down there. And there's your curve. And then you're going back up here. Okay. Okay, sorry, let me just redo that. This is correct, but I need to explain something to you first. Okay, let's go back and trace the steps. Okay, although it's correct, but you need to know why I went through. Why did I go up to here? Okay. Now, let's have a look at what's going on. The table is going to assist us. Right, so let's go back. So what do we know? That this is a turning point. The y-intercept, when x is equal to 0, we said y is equal to positive 8. That's somewhere around here. Now, okay. Now this graph has to go down. Where was my 2, negative 8 was here. Okay, that's my 2 and negative 8. Now this graph has to go down. Remember this value here? That was 1. So when it comes down to join up here, is it going to come this way, in between 1 and 2, and maybe come here? It's a rough sketch now, difficult for me to be 100% accurate. So I'm going to use the table now. That's why we got the table. Okay, so I'm going to come down here. Am I going to pass through in between 0 and 1, or in between 1 and 2? So go to the table. So what do we know? When x is equal to 0, y is equal to 8, there's a point. Can you see that? What's the next point? When x is equal to 1, y is equal to minus 2. So that means when x is equal to 1, y is equal to minus 2, somewhere around here. So that means this graph, before it reaches this point, it needs to pass in between 0 and 1. It can't go in between 1 and 2 and come back that way, understand? So, when x is equal to 1, y is equal to minus 2, that means this graph is going to pass in between 0 and 1 and turn there. We know the turning point. Now it turns and it goes back up. Now, is it going to go in between 1 and 2? Or in between 2 and 3? Or in between 3 and 4? Or maybe it's going to go there. Okay, we just don't go and sketch anything here. You check your table now. So what do we know? The corresponding y value here is negative now. So when x is 1, it's a negative. When x is 2, it's still negative. But now, this is the main point. This is the whole idea of this type of question. Is for you to understand what goes on here. Okay, there is a change. There is a change. There was also a change here too, which I forgot to mention. Okay. There was a change. There's a change here. There's also a change here. But let's focus on this one because we're going up. So there's a change from negative to positive. So where are we? We are at this point, and if you look to the left, it's a negative y value. Can you see that? When x is equal to 2, y is equal to negative 8. But when x is equal to 3, all of a sudden, what is y equal to now? Y is equal to 2. So where is my 2? My 2 is, I'm putting my 2 somewhere around here. Okay, so that means now a change from negative to positive indicates an x-intercept, just like what happened here. A change from, this was a change from positive to negative. Okay, from positive to negative, there's an x-intercept. From negative to positive, also an x-intercept. So we are going up there, and there, and this is your graph. Right. When x is equal to minus 2, y is equal to minus 8. So look at how many changes happen here. We didn't even notice this one. There's a change from negative to positive here too, in between minus 1 and minus 2. So we are going down there, and then our negative 8 is somewhere around here. Okay, so there are 3 x-intercepts here. You can see that? There's one here, one there, one there. What are you looking for? The change between a negative and a positive y value indicates that the graph passes through the x-axis. Right. Now, we didn't label this. What was this turning point? This was 2 minus 8. Label your graph. F of x is equal to 2x cubed minus 4x squared minus 8x plus 8. Right, so that was our just 2 marks, but very important to understand what's going on. Right. Now, the last part, which is Newton's methods. Okay, let's do Newton's method. Alright, so I'm going to erase this. Right, so there are three changes, that three x-intercepts. Now, which one do we want to find? So, let's read this question. An estimated root of the graph is 0,7. That means we're talking about this one here. Right, that's an estimated root. Use Newton's method to determine a better approximation. Right, so let's write Newton's method down. So Newton's method works like this. So x of, let's say n, is equal to x of n minus 1 minus f of x minus 1 all over f prime of x n minus 1. Okay, so that is Newton's method. Don't get confused with the n minus 1. It just means that if I want to find the first estimate, let's say I call this x1, or let's say if I call this x2, it means I need to substitute the previous value, which is x1. That means if this is 2, 2 minus 1 is 1. Now, we are given a value, so it's easy to just use the value. So what we're going to do? We're going to substitute. So let's let x1, which is given, equal to, what was it? 0,7. Okay, so therefore, x2 is going to equal to x1 minus f of x1 all divided by f prime x1. Okay, x2 is my next estimate. Okay, so in order to find the next estimate, I need to use a previous value which was given to me, which I'm calling x1. So now, x1 minus, what is f of x? F of x is 2x cubed minus 4x squared minus 8x plus 8 all divided by f prime x, which is 6x squared minus 8x minus 8. Now what do? You just substitute this value into this. Alright. So now what am I doing? Okay, let me just write this down. So these are all x1, 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 x1. Okay. So what is x1? It's 0,7 minus, substitute here, right, so this was, I'm just reusing a different color to show you the substitution. So that is 0,7. 0,7, 0,7, 0,7, 0,7, 0,7. Let's type it out. So we have x minus, use your fraction button for this part here. You're going x minus, use your fraction button, and now type out the numerator there, which is 2x, that is x. 2x to the power 3 minus 4x squared minus 8x plus 8 divided by 6x squared minus 8x minus 8, and we are substituting 0,7 and see what we get. When we substitute 0,7, I'm getting 2, 1, 4, 7 divided by 2665. Let's convert this to a decimal. It's 0,805. So it's going to be 0,805,628,5178. So there is a better approximation. If I want a value that's more accurate, a better approximation than this one, then what will I do? I will take this 0,8, whatever this is, and go back, and instead of 0,7, put 0, the same answer that I just worked out, into the same formula. Okay, let me just show you, since I got the calculator, which will do it fast for me. If I want a better approximation, so let's say if I want x3, then I will go x2 minus f of x2 divided by f prime x2. So now if I substitute this 0,8, so that's 0,805,628,5178, then I get a 0,8060634186. Let me just see if I can get a better approximation. Let me just do it again. But for the exam purposes, this is your final answer. It's fine. Okay. But let me just do a better approximation. So 0,8060634186. If I do this, then I'm going to get 0,8060634335. Let me do it one more time. Look at these values, how similar they are compared to the previous one. Let me try this one. I'm putting this back into the formula, which is 0,8060634335. And I get 0,8060634335. This is the best approximation. Okay, so this was your input. This was the output. So the best approximation is when your output is equal to the input. Like x5 is equal to x4. That means this is the x-intercepts. Right, so you don't have to do it for this exam, but when you're going to study in DUT or any university of technology and you're doing this section, then you have to do it until your output is equal to your input. In N5, they asked you, they didn't say how many times you must use the formula, so you use it one time only. So your answer, you just stop here, 0,80806. Certain exam papers, they will ask you to use the formula twice. So then, that won't be your answer. This will be your answer, you understand? If they ask you to use the formula 3 times, then this will be the answer. It's almost the same if you're rounding off. It's just these last few decimal places which are different. So that was Newton's methods.